Non-assignment operators. Let's discuss all the different operators provided by VB.NET with usage details. Addition. Adds two operands together, producing a sum. Unary plus. Ensures that an operand retains its current sign, either positive or negative. Since all operands automatically retain their sign, this operator is usually redundant. Subtraction. Subtracts one operand, the second, from another, the first, and returns the difference. Unary negation. This reverses the sign of its operand. When used with a literal number, it results in a negative value. When used with a variable that contains a negative value, it produces a positive result. Multiplication. Multiplies two operands together and returns the product. Division. Divides one operand, the first, by another, the second, and returns the quotient. If the second operand contains 0, a divide by 0 error occurs. Integer division. Divides one operand, the first, by another, the second, and returns the quotient, first truncating any decimal portion from that result. If the second operand contains 0, again a divide by 0 error occurs. Modulo. Divides one operand, the first, by another, the second, and returns the remainder as an integer value. Exponentiation. Raises one operand, the first, to the power of another, and that is the second. String concatenation. Joins two operands together and returns a combined string result. Both operands are converted to their string equivalent before joined together. Conjunction. Performs a logical or bitwise conjunction on two operands and then returns the result. Disjunction. Performs a logical or bitwise disjunction on two operands and returns the result. Short-circuited conjunction. This operator is equivalent to the logical version of the AND operator, but if the first operand evaluates to false, the second operand will not be evaluated at all. Short-circuited disjunction. This operator is equivalent to the logical version of the OR operator, but if the first operand evaluates to true, the second operand will not be evaluated at all. Negation. Performs a logical or bitwise negation on a single operand. For logical operations, the result will be true if the operand evaluates to false, and false if the operand evaluates to true. Exclusion. Performs a logical or bitwise exclusive OR on two operands, and returns the result. Shift left. The shift left operator shifts the bits of the first operand to the left by the number of positions specified in the second operand, and then returns the result. Shift right. The shift right operator shifts the bits of the first operand to the right by the number of positions specified in the second operand, and then returns the result. Equals comparison. Compares two operands and returns true if they are equal in value. Not equals. Compares two operands and returns true if they are not equal in value. Less than. Compares two operands and returns true if the first is less in value than the second. When comparing string values, the return is true if the first operand appears first when sorting the two strings. Greater than. Compares two operands and returns true if the first is greater in value than the second. When comparing string values, the return is true if the first operand appears last when sorting the two strings. Less than or equal to. Compares two operands and returns true if the first is less than or equal to the second. Greater than or equal to. Compares two operands and returns true if the first is greater than or equal to the value of the second. Pattern comparison. Compares the first operand to the pattern specified in the second operand and then returns true if there is a match. The pattern operand supports some basic wildcard and selection options, and it is fully described in the documentation supplied with Visual Studio.NET. Type comparison. Compares the first operand to another object, a data type, or nothing, and returns true if there is a match. Negated type comparison. This operator is a shortcut for using the is and not operators together. Instance comparison. returns the data type of a value or variable. The type of every class or data type in .NET is implemented as an object based on the system.type. Delegate retrieval returns a delegate that represents a specific instance of a procedure or method. Type retrieval returns the data type of a value or variable, just like the type of operator. However, getType works like a function and does not need to be used with the is operator. Assignment operators. The assignment operator does update the operand that appears on its left side. In addition to the standard assignment operator, Visual Basic includes several operators that combine the assignment operator with some of the binary operators. The table here lists the assignment operators provided by VB.NET. These assignment operators are just shortcuts for the full-bodied operators. For instance, to add 1 to a numeric variable, you can use either of these two statements. Arrays. An array assigns a numeric position to each item included in the set, starting with 0 and ending with 1 less than the number of items included. An array of 5 items, therefore, has elements numbering from 0 to 4. Multidimensional arrays. Visual Basic arrays support more than one dimension or rank. The dimensions indicate the number of independent ranges supported by the array. A two-dimensional array includes 2 delimited ranges, forming a grid arrangement of elements, with separate ranges for rows and columns. This is how a multidimensional array will look. An array can have up to 60 different dimensions, although there are usually better ways to organize data than breaking it out into that many dimensions. Now then, let's work with a sample program explaining the concepts of arrays. In Visual Studio 2008, create a new Windows Forms application and name it Array. When the designer for Form 1 appears, add a list box control to the form. Using the Properties window, set its name property to First Friends and its integral height property to False. Add a button control to the form. Set its name property to btn array element and set its text property to array element. Arrange your controls so that your form should look like this. Double-click the button control and paste this code in its click event. Now place your mouse pointer in the Code Designer window and paste this procedure snippet. Now then run the application by pressing F5. When the form loads, click the Array Element button and the list box on your form will be populated with the name Sam. Now, let's discuss how this works. First, we are clearing the list box by calling the clearList method. In the second line, we are declaring the array by specifying its data type and a size. In this case, we're specifying an array of type string and also defining an array size of 5. The way the size is defined is a little bit quirky. We have to specify a number 1 less than the final size you want. When done, we have our array and we can access each item in the array by using an index. The index is given as a number in parentheses after the name of the array. Indices start at 0 and go up to 1 less than the number of items in the array. This section of code sets all 5 possible items in the array to the names. Just as we can use an index to set the items in an array, we can use an index to get items back out. In this case, we're asking for the item at position 0, which returns the first item in the array, namely Sam. Finally, the method that we defined contains only 1 line of code. This method merely clears the items collection of the list box. Structures. Structures can be defined as a tool for handling a group of logically related data items. They are user-defined and provide a method for packing together data of different types. Structures are very similar to classes. Like classes, they too can contain members such as fields and methods. The main difference between classes and structures is classes are reference types and structures are value types. In practical terms, structures are used for smaller, lightweight items that do not persist for long, and classes are used for larger items that can be expected to exist in memory for long periods. Let's work with a sample program explaining the structure concept. Create a new Windows Forms application in Visual Studio 2008 and name it Structure. Drag and drop 4 label controls, 4 text box controls, and a button control to your form. Arrange all the controls so that your form should look something like this. Set the name properties as follows. Set the text properties as follows. Now then right-click the project name in the Solution Explorer. In the list, move your pointer to Add in the selection list and click on New Item. In the New Item dialog box, select Class and enter Customer in the name field, and then click the Add button to have this item added to your project. When the code editor appears, replace all existing code with this code. Paste this block of code snippet in the form load event. Double-click the button control and in its click event, paste this code. Now run the application by pressing F5. In the output window, click the List Customer button and you should see results similar to this. Now let's explore the working of this program, shall we? We're defining a structure using a structure-end structure statement. Inside this block, the variables that make up the structure are declared by name and type. These variables are called members of the structure. Notice the keyword public in front of each variable declaration, as well as in front of the structure statement. The public keyword means that we can refer to the member such as first name outside of the definition of the customer structure itself. In the second code snippet, in the button click procedure, we're defining a variable of type customer using the dim statement. Then we can access each of the member variables inside the customer structure, the obj customer, by giving the name of the structure variable, followed by a dot, and followed by the name of the member. Here in this, we are performing the action of defining input to fields. The display customer procedure simply accepts a customer structure as its input parameter, and then accesses the member of the structure to set the text properties of the text boxes on the form. Working with array lists. Suppose you need to store a set of customer structures. You could use an array, but in some cases the array might not be so easy to use. Under this circumstance, the array list provides a way to create an array that can be easily manipulated as you run your program. Now let's work with a sample program explaining the concept of array lists. Let's use the same structure program that we used in the previous lesson. Make the form larger, move the existing controls down, and then add a new list box control and arrange it such as this. Set the name property of the list box to First Customers and its integral height property to False. Open the code editor for Form 1 and add the member to the top of the class definition. Now, paste this method to Form 1 to create a new customer. Now double the button control and its click event, delete the previous code, and make this code change to create some customers. Now then, run the application by pressing F5 and click the List Customer button. You should see results looking like this. You are adding customer structures to the list, but they're being displayed by the list as structure.customer. This is the full name of the structure. The listbox control accepts string values, so by specifying that you wanted to add the customer structure to the listbox, Visual Basic 2008 called the toString method of the customer structure. By default, the toString method for a structure returns the structure name, not the contents that you want to see. So what you want to do is tweak the customer structure so that it can display something more meaningful. To do that, follow these steps. Open the code editor for customer and paste this method to the structure, ensuring that it is below the member declarations. Now, run the application again by pressing F5. Now click the button control and you'll get an output such as this. Now let's explore how this ArrayList application works, shall we? Whenever a customer structure is added to the list box calls the toString method on the structure to get a string representation of that structure. With this code, we are overriding the default functionality of the toString method, so that rather than returning just the name of the structure, we get some useful text. An ArrayList can be used to store a list of object structures of any type. Here we are creating a method called createCustomer that initializes a new customer structure based on parameters that were passed then to the method. After the structure has been initialized, we add it to the ArrayList stored in the obj customers with this command line. Again, we are adding the same to the listbox control. Here in this code snippet, we are creating some customers that we can call to add new members to the ArrayList and to the listbox control when the user clicks the List Customers button.